Okay, welcome. So what I want to do now is show you how to write the equation of a polynomial when given the zeros. And the important thing with this one is we're going to work on when we have a irrational zero. So it's really important that we kind of go back to our initial kind of warm-up that we talked about where the irrational zeros, kind of come from. So just to kind of go back through that example here, if we were to solve in the equation 7x, squared, or f of x equals that, and then we set it equal to 0. As we go ahead and solve, using in this method, the square root method, we get x squared equals the square root of 7, right? But remember, x equals positive 7. And then now we need to introduce the square root. And the important thing when introducing the square root is we have to include the plus or the minus. So x equals, plus or minus the square root of 7. We have to include the positive and the negative. And another way to look at this, what we talked about, this is a difference of two squares, right? But just across irrational numbers. So this could also be factored, or you could take the zeros and write them as the factors as x squared root of 7 times x plus square root of 7. So what we do is we call this the conjugate pair. And it's very important for us to understand whenever you see one radical, and part of a polynomial, the conjugate pair is going to exist. So what that means is sometimes we're going to provide you with both radicals, and it looks like actually I don't think in any of my examples I do. So each one of these you have to understand that for every radical that you have the conjugate pair. You have the positive as well as the negative version of that radical. And then really the process that we're going to follow through this example, through these 4 examples, is really the process that we did with real zeros. We're going to take our zeros, if we're provided zeros, write them as factors, and then just multiply them and to give them into our polynomial form. So I'm going to work a little bit quicker with this, not as much, going through the basics of this, but if you follow like the videos for our factoring, it's basically the reverse operations of taking a polynomial, factoring it, using the zero product property, and then solving. Basically what we're doing is we're just working our way backwards. So for this first one, I will kind of work it out a little bit longer, and then you can kind of see that process that will kind of continue for the rest of them. All right, so these are our zeros. That means all of our zeros are the solutions that make f of x equal to 0. So we can say x equals negative square root of 3. Now remember what I talked about. If negative square root of 3 is a 0, that means x equals positive square root of 3 also has to be a 0. Then we have x equals 1/2 and x equals 0. Okay, now the next step is to write these as factors. So there you can see these are basically going to be kind of like what I did over here. I mean, it's fairly simple. You're just going to add the square root of 3. So we could say x, I'll just set this in there. X equals 0. So we can write this as, I don't know why I want to put that there. So if I add this as, x plus the square root of 3 equals 0. And this would be x minus square root of 3 equals 0. Now here's a special case. You could subtract the negative. You could subtract the 1/2. Then you'd have x minus 1/2 equals 0. The problem with this method is if you do that, well, then what you're going to have is you're going to have fractions when you multiply everything. And we don't want to have fractions, when we multiply everything. We want everything to have to be integers as possible. So what we can do is multiply by a 2 on both sides to undo the division of 2 and then subtract the 1. So when we do that, what we'll get is 2x minus 1 equals 0. And again, I want you to point out, if you add the 1 divided by 2, you get x equals 1/2. Okay, so this is just an easier way, and then we have x equals 0. Okay, so remember, each one of these, this is like how we got to the zero product property, or from the zero product property. So what that means is each one of these is a factor. So we could multiply these all together. If we were solving, we would have set these all equal, all multiplied together equal to 0. So now we can just rewrite this expression as like the zero product property from x plus the square root of 3 times x minus the square root of 3 times 2x minus 1 times x. I'll just put it in there, equals 0. Now, technically I'm saying equal 0 because I'm trying to, this is, if we had this problem and I said solve this, we said, oh, it's the product equal to 0, set each and every factor equal to 0, and then you can solve. But remember, we're kind of working backwards. So rather than setting this equal to 0, I'm going to set this equal to f of x because I'm not trying to use the zero product property, but I understand where this is coming from. So I'm just going to put the f of x over here because that's what we're trying to do, is trying to find the equation of the polynomial. Okay, so now it comes into the multiplication portion of this. And really, it doesn't matter what you like to do. I prefer to multiply using the difference of two squares, always kind of first. And just remember when you have one positive, one negative, that the middle terms are going to add to 0, so we don't need to. I'll do this once, and then for the other videos, I'm not going to do that. So if we just apply distributive property here, x times x is x squared. X times negative 3x is negative x squared root of 3. X times square root of 3x is positive x square root of 3. Oops. And then square root of x times negative square root of x is going to be a negative square root of 3 squared. Okay, now again, that's still being multiplied. This product is still multiplied by this product, which I will apply distributive property here to give me 2x squared minus x. All right, now let's go ahead and simplify this out a little bit. So I have x squared. Now again, here's what I was talking about. This is the negative version, that's the positive version of the same value. So they add to 0, so we don't need to write them. 3 squared is 9. Square root of 9 is 3, so that's going to be minus 3. And then that's going to be times 2x squared minus x. Now basically what we're looking at, guys, is just a binomial times a binomial. So therefore I'm just going to use FOIL again, kind of like what I did for the multiplication of these other two. And as we just go ahead and multiply this out, x squared times 2x squared is 2x to the 4th. X squared times negative x is a negative x cubed. Negative 3 times 2x squared is going to be a negative 6x squared. And then negative 3 times negative x is going to be a positive 3x. And again, if we think about these as zeros, right, these are all the x-intercepts that we have, you can see that well, since you have the positive version has to occur. You can see here we have 4 zeros, so therefore our degree should be 4, and that would make sense as everything else. So there, that should be positive. Yep, very good. All right, so now let's kind of work through this again in another set. Now here you can see that we have negative square root of 3 and positive square root of 3. So again, another difference of two squares. I have positive 2 square root of 5, so guess what? Negative 2 square root of 5 needs to exist as well. So rather than writing these all as zeros, I'm just going to go right into the factored form of this. I'm going to say this polynomial is going to be written as y equals x minus 2 square root of 5 times x plus 2 square root of 5 times x minus 3 times x plus 3. Okay, and if you wanted to go through the steps like I did here, set each and every one of these equal to x, subtract them equal to 0, you'd get the exact same thing. But I'm just kind of like simplifying my steps here because it's the same process really. Now I just want to get to this multiplication. Now again, I'm going to do multiplication using the difference of two squares. I'm not going to multiply everything. All I'm going to do is multiply the first term and the last term. First terms and the last terms. Because again, these middle terms add to 0. All right, so when I go ahead and multiply this one out, I get x times x is x squared. Now I will multiply this through, so negative 2 times positive, so negative 2 square root of 5 times 2 square root of 5 is going to be a negative 4 square root of 5 squared, which is just 5. Well, I'll write it in there one more time, why not? Okay, and then that's going to be times x squared minus x times x is x squared, negative 3 times 3 is negative 9. All right, so let's simplify that one more time. So this becomes x squared. Let's see, square root of 5 squared is just going to be 5. 5 times negative 4 is negative 20, so that'd be a negative 20 times x squared minus 9. Okay, now this is not a difference of two squares, not positive and negative, and they don't have the same term, so we actually need to multiply this one out. And again, I'm setting my equation equal to y. Basically, you could do it by f of x as far as the function, if it's, equation. Either way, it's really kind of interchangeable, depending on really what the question is really trying to get at. But now we need to use, complete FOIL, multiply every term by every term. So in this case, I have x to the 4th, x squared times negative 9x squared minus 20x squared. And then negative 20 times negative 9, well, negative 2 times negative 9 is negative 18, so add a 0, so that's going to be a negative 180. Okay, and then I can combine my like terms here, so y equals negative x to the 4th minus 29x squared, that's a 9, minus 180. Okay, all right, so now let's get to the next one, and the next one These next two examples are a little bit more confusing. And so what I'm going to do is I'll do one way the long method, and then the second way I'll do the short method. And there's really not so much as far as like long method, short method. Well, it is. But I'll give you kind of a shortcut. And if the shortcut doesn't make sense, then please just go back and use the long method, okay? Now, the important thing to look at this is there's a couple things going on. We have our zero is a, we have our zero in this case is two terms. It's not just one term. It's a rational term and an irrational term. And you remember, this came up a lot when we did the, if you look back in the warm-up, when we did the quadratic formula, we ended up with zeros that were in this format. So again, we still have the complex conjugate. That doesn't go away. That's 1 plus the square root of 2. But the multiplication for this is going to be a little bit more difficult, and we'll just kind of work through our way from there. The other thing that's important to understand is here now we're introducing multiplicity. So in this case, I have a 0 of 1, but the multiplicity is 2. That means 1 is being repeated. So there's a couple ways you could do this. You could say, take the 0 and raise it to the power, or just write x equals 1 twice. All right? It doesn't really matter which way you do it, but you need to make sure that that multiplicity is represented. So let's actually write this one out. Let's do this the long way. So let's do x equals 1 minus square root of 2, x equals 1 plus square root of 2. And then we have x equals 1 and x equals 1, because again, multiplicity just means the 0 has been repeated. So now as we set these equal to 0, you're going to have to subtract 1 and add square root of 2. Subtract 1 and subtract square root of 2. So therefore, we'll have x minus 1 plus the square root of 2 equals 0. X minus 1 minus square root of 2 equals 0. And then x minus 1 equals 0 and x minus 1 equals 0. Okay, so again, these are your factors, right? You can group these up and then multiply them. So all of these multiplied together are going to give us our polynomial. So I'll just use again y equals. So I'll say y equals x minus 1 plus the square root of 2 times x minus 1 minus the square root of 2, and then times x minus 1 times x minus 1. All right, and then again, remember x minus 1 times x minus 1 could be x minus 1 squared, which we'll get to. Now, if I want to multiply these, you can just treat these as you have a variable, an integer, and then an irrational number. So let's go ahead and use the box method for this case to help us with that. Because you have basically a trinomial times a trinomial. So I'm going to use the box method here. And the box method is really, again, just a way for me to organize all of this. So I have x minus 1 minus square root of 2. Okay, x times x is x squared. X times negative 1 is negative x. X times negative square root of 2 is negative x square root of 2. X times negative x, that's a positive 1. This becomes a positive square root of 2. Again, all I'm doing is multiplying the length times the width of each box. So x times square root of 2 is x square root of 2. Square root of 2 times negative 1 is negative square root of 2. And then square root of 2 times negative square root of 2 is going to be a negative square root of 2 squared, which is just going to be a negative 2. Okay. Now again, let's look at the terms that are going to basically add to 0. So we have a positive x square root of 2, and we have a negative x square root of 2. We have a negative square root of 2, and we have a positive square root of 2. So I don't need to rewrite these because these are going to add to 0. But what we do is we have two common terms, negative x, and then we have our two integers here, 1 and 2, that we can combine. So when we combine all of this, we get y equals, let's see here, that's going to be x squared minus 2x minus 1. Now, if you wanted to check your answer, you could do the quadratic formula and make sure you get that back, but I wouldn't really recommend that unless you have some time on your hands or that you would need to. X minus 1 times x minus 1, if you want to multiply that out using box method, that's fine. You should understand that that's going to be a perfect square trinomial. So that's going to give us x squared, x squared minus 2x plus 1. Okay, so now, guess what? We have another trinomial times a trinomial. So I'm going to use the box method again. I'll use different letter. I'll use red now this time. But we're going to use the box method again to multiply these. So you can see how there's a lot of multiplying, in this. And as long as you're okay with multiplying like trinomials times trinomials, like it's not bad. It takes a little bit longer than the shortcut, but it makes sense, right? I mean, it's a process that you can follow no matter what type of numbers that you're dealing with. So now I'm multiplying this trinomial times this trinomial. Again, you could use distributive property. You could distribute all of these if you want to, and that's perfectly fine. I just like using this box method to keep everything organized. So here I'm going to do x squared times x squared, which is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times x is x squared. Negative 2x times x squared is a negative 2x cubed. Negative 2x times negative 2x is going to be a positive 4x squared. Negative 2x times 1 is a negative 2x. Let's see, x squared times negative x is a negative x squared. Negative 1 times negative 2x is a positive 2x. And negative 1 times and positive 1 is going to be a negative 1. Now, again, as long as you have these written in your order, you can see here that on the diagonal, we have like terms that combine. Right? And that's what I kind of like about that. I think it's just easier to group them. When you use the vertical method of distributive property with all these terms, you can just, I think, in my opinion, it's just easy to make mistakes. So in this case, we have y equals x to the fourth. Negative 2x cubed plus negative 2x cubed is going to be a negative 4x cubed. Then I have negative x squared. Oh, those goes to 0, don't they? X squared, 0. So those goes to 0, so I'm just left with a positive 4x squared. And then that goes to 0, so then I'm just left with a minus 1. Okay, very good. All right, so now on to the last one. Then let's kind of work on showing you guys a trick for this. So again, here we have this repeated zeros, all right? Now, fortunately, this one is at x equals 0, so I can just take that factor and then raise it to the power of 3. So you can do that as well. Now, I'll show you what to do with that. And then we have this negative 5. I had to add something here. All right, now, hopefully you kind of get the process of setting equal to x and then setting equal to 0 and then going to the factors, because I'm going to skip some work here and just go straight to the factored form. And I'll use f of x notation here instead of y. So now the factors here would be x minus 1 minus 4 square root of 3. Right? Because if I was going to multiply all of these times there, we know that 1 minus 4 square root of 3. So that means my other factor is going to be x minus 1. You'd still have to subtract the 1, but now you'd have to add the 4 square root of 3. If I was going to set x equal to 0, like x equal to 0, and then raise it to that, I would have x minus 0. You could write it as x minus 0 cubed. Right, linear factor to the 0 multiplicity, or we can just write it as x cubed. And then we have this 0, x minus 5, so therefore the factor is x plus 5. Okay, and obviously we could write those out in the front. That would work too. All right, so here's where the new method works. And a couple things to kind of recognize with this method is that we actually have a difference of 2 squares. And that comes into grouping. If you group the x minus 1s in these first two terms, you see that these are exactly the same. And then if you kind of underline the 4 radical 3, you understand that these are exactly the same. The only thing that's different is you have a minus and you have a plus. So again, it's kind of like a minus b, where a represents x minus 1 and b represents 4 square root of 3, times a plus b, where a again is x minus 1 and b is 4 radical 3. So what that means is I can just rewrite this using the difference of 2 squares. So what I'll do is I'll have this x minus 1 times, again, when you multiply the difference of 2 squares, you don't need to multiply everything. Just multiply the first terms, multiply the last terms. So you can see, like when we did down here, I multiplied all this, but a lot of it was like, it just went to 0, right? I mean, obviously doing this method, you had to do everything, but we did a lot of extra multiplication. So here, I'm just going to multiply x minus 1 squared, and this will be minus 4 radical 3 squared. Okay, and then we'll still have the x cubed, and let's distribute that actually. So we'll have x to the 4th actually. So we have x to the 4th plus x 5x cubed. Okay, so let's distribute that. Okay, so now the only problem I see, really with this method, and if it's hard sometimes to, understand this pattern, but once you see that pattern, then you obviously have to multiply this out. Now again, this is a perfect square trinomial, kind of like what we did over here. Like you should be able to multiply this rather quickly into its perfect square trinomial. So again, this becomes x squared minus 2x plus 1. So again, this is 4 square root of 3 squared. Then you have to multiply it by the negative. So make sure you do that at the end. So 4 square root of 3 squared is going to be 3 times 16, which is going to be then minus. So it's going to be a minus a 48. Okay, so again, it's 4 square root of 3 times 4 square root of 3. So 4 times 4 is 16. Square root of 3 times square root of 3 is just going to be 3. 3 times 16 is going to be 48. All right, and then we'd multiply. And now you just combine those. So we have x to the 4th plus 5x cubed. Okay, and then here we have x squared minus 2x. 1 minus 4 is going to be minus 47. Oh, I don't want to multiply those. That's not going to be fun. X to the 4th plus 5x cubed. See what I got there. Cool. I got my nice little handy calculator I work with. All right. Because I don't want a 5. I guess, I could do it for 100. Funny. That'd be times 5, so times 3, so minus 15 from 150, so it'd be 135, I believe. Yeah. All right. We'll come back to it. All right. Anyways. Now let's just go in this method, rather, we could use the box method, but let's do something else. Let's do the vertical method. So what I'm going to do is just going to multiply these first rows, and then for each multiplication after that, I'm just going to put in a different row. So first one, I'm going to do x here, x squared times everything will be in the top row, and then each multiplication will be below it. So here I have x to the 6th, because remember you add the powers, plus 5x to the 5th. Now let's do the negative 2x. So now I do negative 2x times x to the 4th, which is negative 2 x to the 5th. And then negative 2x times 5x cubed is going to be a negative 10 x to the 4th. All right. And then now I'll do my 47. So negative 47 times x to the 4th is negative 47 x to the 4th. And then negative 47 times 5, I think I said was 135. Let's just check it, just to make sure that I'm right. 235. Yeah, that's right. Yeah, 20. Well, I don't know why I was getting the 135. Yeah, 235. Because you have 50, so 50, 100, 150, 200. There you go. So 235, so that's a negative 235. And that's x cubed. And what's nice about this vertical method is obviously there's only one term that was x to the 6th. So therefore, that's x to the 6th right there. This becomes, now you're just adding the leading coefficients, keeping the exponent the same. So this becomes a positive 3 x to the 5th. This becomes a negative 57 x to the 4th. And this becomes a negative 235 x cubed. Okay. And again, you can see here, now the one thing I forgot to mention on this one, like there's only 1, 2, 3, 4 zeros, right? But remember, there's really 1, 2, 3 zeros, and then here are 3 of them because they got repeated. So that's why it adds up to a power 6. And over here is the same exact thing. You have 1, 2, 3, 1, 2, 3, 4 is your degree, right? Well, it's here you have 2 zeros, and then here is 1 0, but it's repeated twice. So you have, that's why it shows up twice. So there you go, ladies and gentlemen. That is how you write the equation of a polynomial when given the zeros, and especially the irrational zeros. And the main important thing to remember is just to apply those conjugate pairs. You got to remember the conjugate pairs, and then also look into using, the multiplicity if you have any of that. And there's the long version and a shortcut version. But otherwise, hope that helps. Now let's get on to the last example.